All right, welcome to those of you who were able to make it to class today. If any of you came to class Friday, you found out we did not have class Friday. I was out all day, so I did not have any Google Meets at all. I went to see my oncologist, which is a cancer doctor, and he did confirm that my bone marrow transplant has officially failed and that my leukemia has returned. So that has been doubly checked now and confirmed. So I was not able to come to school Friday and was out for that. With that, there may be other days that I will be out going forward. I'm going to be starting a chemotherapy pill that I will take daily that will hopefully get everything under control. And if that does, that will help keep me here much more often than if it does not work. If it does not work, then we'll have to be moving towards the hospitalization and bone marrow transplant therapy, which is taking all my bone marrow out and replacing it with somebody else's, which we did 3 years ago, but it did not stick. Mine fought its way back and it's been killing out the new stuff, which is just the opposite of what was supposed to happen. So, assuming this chemo pill works, I will be able to be here and be teaching without all of the interruptions of hospital stays. So we will see. I do know that I'll be out sometime this week to have a bone marrow biopsy. That's where they go take a piece of my bone marrow and take a look at it. That's just as much fun as it sounds like. They have to take a needle and crunch through the bone to get inside there to pull out some of the bone marrow from the middle. So they'll be doing that at some point this week. I have not had that scheduled yet. They should be calling me. And as of yet, no missed calls. So waiting on that. Also, next week, I will be out Monday next week where I have to go to Little Rock and see my cancer doctor in Little Rock. So I'll be gone that whole day. So I don't know if it's going to be an A day or a B day or when that will affect us yet. But when I find that out, I will send an email out just to let everybody know the situation on class. So there will be times, certainly going forward, that we may not have class due to that. So I will try to have a video or something posted at some point that week. It may not be the day I'm gone. If I'm just bad that day and can't get to school, I probably won't be able to have a video ready either, but I will get one up when I can to help with that. So just letting you know where we stand. That's when life outside this virtual room affects life inside this virtual room. And that's where we are on that. So we'll see how things go. Certainly hoping this pill does its job and we won't have too many nasty side effects. All pills have side effects. Chemo pills have nasty side effects. Like the last chemo pill I was on made me deaf in this ear. So don't even need the headphones. I need like a half a headphones, kind of like an eye patch instead of glasses, right? If I could just do an eye patch thing, that'd be cool. But I might as well have them both on. But this one does me no good. So we'll see. This is not the same chemo pill. This is not one that causes deafness. This is one that causes heart attacks and strokes. So that's something to look forward to. But we're going with a low dosage, and hopefully we'll avoid any further complications with that. Today, this week, for Algebra 2, we have two things that is due this week. Number one is the lesson 3.08. Investigating quadratics. This is kind of cool. We're getting into something that we don't normally study with quadratics. We usually look at quadratic formula and we look at x squared and the axis line, axis of symmetry and those kind of things. This lesson is going to get into the directrix and focal point, which we don't often talk about in study quadratics. So this is just one lesson that's on that. And then also this week you have the practice test. That means we are at the end of module 3. So this week after this lesson, you have this lesson and the practice test. So I will be taking the practice test myself. I'll be recording that. I will put that online where you can, if you're struggling with the practice test, if there's some problem you can't figure out, you can go watch me do that same problem or a problem very similar to it. So if you're in trouble with number 12, go look at my number 12 and see how I did it. And that should help you hopefully figure out what you were struggling with on that problem. But I'll be doing that this week sometime soon and get that posted as quick as I can up online so you'll have the practice test. So today we're going to look at that 3.08 investigating quadratics lesson. And then later on this week, like I said, I'll have the practice test up. So let's look at what it's telling us for this lesson that we have this week. So let me put up on the screen. So we're talking about, in this lesson, how to derive a quadratic equation from a parabola using focal length. Focal length. Well, let's talk about what in the world all this is first. If we have a parabola, right, we know that's it. When we graph a quadratic equation, it will look something like that, right? It'll have a U-shaped or it'll be upside down U. We know that there's always a vertex, right? The vertex, which is the turning point for the parabola. But there's a point we haven't talked about, and it'll be up here somewhere, and it's called the focus. Focus. And if the vertex is the point H comma K, the focus will be the point H comma K plus P. And we'll talk about that P in a moment. And then there's also something called the directrix, right? Directrix. And it is a line that will be down here. And this line, right, there's directrix. It is the line y equals K minus P. Okay, so what it's emphasizing here is that the distance from the vertex to the focus is going to be the same as the distance from the vertex to the directrix. Because the vertex is at HK, and if we add this P on there, it'll take us up to there. If we subtract P, it'll take us down to there. And so the P is the focal length. Focal length. We call it P. P is the focal length. And that basically is the length of the focus from the vertex. Now, there's something very interesting about this point. If you choose a point, let's say we chose this point up here, the distance from the focus to that point and from that to a parallel line to the directrix will be the same. Now, not the way I drew it. I didn't draw it that perfectly, but it should be the same from here to here and here to here, a perpendicular line. So these lines will always be the same in every point along that parabola on either side. So the whatever long it is from here to here should be the same as it is from here to here. That's why it's the focus. The focus and the directrix work together because they provide a length that will match. This focal length, this P, will be the distance they are away from the vertex. Okay, so if we're trying to derive an equation, the equation is going to be in the form of the vertex form of a quadratic, which will be y equals a, whatever a is, x minus h squared plus k, right? Where hk is our vertex, and a will be some coefficient that basically affects how skinny this is or how wide this is. And the way we can figure that out is a will equal 1 over 4p, and p is that focal length. P is that focal length. So this is an equation you need written down. A equals 1/4 P, knowing that P is the focal length. So what I'm going to do is I'm going to have an actual graph that we're going to use, and we're going to see if we can figure out the equation using this information about the focus and the directrix. The focus and the directrix. So I'm going to use an actual problem from this week's assignment. Let's do that. So if I look at this week's assignment, it says, okay, first off, let's do one. It says derive the equation of a parabola that has a focus at 2, 4 and a directrix at y equals 8. Okay, this is all it tells us about our parabola. So let's put that on our graph. 2, 4. 2, 1, 2, 3, 4. So here is our focus. That's our focus. All right, and we know the focus is going to be somewhere inside the parabola. And the directrix is going to be outside the parabola, the same distance from the vertex. So this says our directrix is at y equals 8. So let's draw that line, y equals 8. Well, this is going to be right here at the top of our screen. So I'm going to draw it in green. Y equals 8 will be this line right there. So this is y equals 8. So this is all the information they gave us about our parabola, and we have to come up with an equation for this parabola, giving just this focus and this directrix. Well, one thing we know is the vertex is always, always, always exactly in the middle between those two, which means our vertex is going to be here. And this is the point 1, 2, 1, 2, 3, 4, 5, 6. So our vertex is at the point 2, 6. So what else we know now is we know the focal length. We know what P is. P is the focal length, and it's how far it is from the vertex to the focus, or from the vertex to the directrix, because those are the same length. So the focus is here. The vertex to the focus is that length, which is a length of 2. So P equals 2. So the other thing we know is that our parabola is going to go down because the focus is inside, you know, so I can make these longer, I guess. Inside. It's not going to go up because that would put the focus outside and put the directrix inside the parabola. Ours is going down. So that's important for us to know that it's going down, because we're going to write an equation for this. Y equals a x minus h squared plus k. We know the a, to find out what that is, it's a equals 1 over 4p. But p is always going to be a positive number because it's the length. It's a length of 2, which means a will always be positive. But that's not how we determine if it's positive or not, just by this calculation, because this calculation will always end up positive. We have to determine if this is positive or negative depending on which way our parabola needs to go. Our parabola is going to go down because it has to be for the focus to be inside the parabola. So we know our A is going to be negative. So let's calculate what our A is. 1 times 4p. Our p is 2. So it's 1 times 4 over 2, or 1/8. Okay, so if we're working on our equation, it's going to be y equals, ours has to be a negative because our parabola is upside down. Okay, now it's x minus the h. hk is our vertex. Remember, our vertex is always in the coordinates hk. So what's our vertex? 2, 6. So this is x minus 2 squared. X minus 2 squared plus k plus 6. So that's it. That is the equation for our parabola. And all they gave us was the point of the focus and give us the line of directrix. And from that, we were able to come up with the equation to graph that exact parabola that will have this focus and directrix. So we're going to put that on a graph right now just to verify that what that says is the same thing. So let me put this graph up on the screen. Type in what we had, y equals negative 1/8. Oh, eighth. There we go. Parentheses, x minus 2, parentheses squared, and then the plus 6. All right, here is the parabola. And we said that the focus should be at 0.24. And the directrix is y equals 8. So that's perfect. So with our vertex at 2,6, that's at 2,4. That is halfway between there and this line, which is at y equals 8. So that would be the focus and the directrix. And we talked about how any point on here will be halfway the same length. So if we chose the point, let's go to 6,4. It's not going to stay up there unless I type it here. Let me type 6,4 in there. 6,4. If we look how far it is from the focus to that point, it's 1, 2, 3, 4. And how long is it to the directrix? It's also 1, 2, 3, 4. Should be the same distance from this directrix line as it is to the focus. We could choose any point. This right here, the length between the blue dot and this point should be the same as if we went straight up to the green line up here. It'll be exactly the same. Every point along there is going to be the same distance to the focus at 2,4 as it is to the line up there at y equals 8. That's why it is the focus and the directrix, because those are exactly the same distance away from every point on the parabola. So, but yeah, graphing proved that we did that correctly. If our problem says to put this in standard form, we still have to figure out this way first, because that's the only way we can go from a focus and a directrix to an equation. But if we want that in standard form, then we just got to simplify it. We got to take y equals negative 1/8. And then we've actually got to square that. So x minus 2 times x minus 2 would be x squared minus 4x plus 4 plus 6. And then we have to take the negative 1/8 times that. So it'd be negative 1/8 x squared. And then negative 1/4 times negative 4 would be a positive 1/2 x. And then negative 1/8 times 1/4 would be a negative 1/2 plus 6. So it'd be plus 5. Well, if we do it improper, do it like that, 5.5 or 11 halves or however we want it. Because negative 8 times 4. So it ended up negative 1/8 x squared plus 12x plus 5.5 in standard form. So the same equation in standard form right there. And if you weren't sure if you got that right, you could always go back to Desmos and you could type this in and see if it's the exact same graph as that. That's the easiest way to check to see if you made that conversion right. Is just go type both of those graphs in and make sure they're identical. Make sure they're identical. So that is how you use this. Go through this lesson. It has some practice problems. You need to practice a few of those. Our assignment has, let's see, 1, 2, 3, 4, 5 of those problems. 5 of those problems. 4 of them are exactly what we did. The 5th one is the same, except it wants you to convert it to standard form. So all 5 of them, you're taking that focus and that directrix, and you're trying to figure out the equation for that parabola. And on the last one, you have to turn around and convert that to be standard equation instead of the vertex form of the equation. So that's it. You have that and the practice test this week. Like I said, I'll be uploading that later when I take the practice test. So that way you'll have that as a review before next week's test. So I won't throw anything else at you. That's all this lesson is. It's about the directrix and the focus. And we don't spend a whole lot of time on that. But it's something it's good to see and be exposed to before you move on and see that in higher math later on. So If there's anything you have questions on, please hang around. Otherwise, I will let you go for today. And have a great week.
Let's get out of here. Word to your multiples. Math, baby.